Just a word about continuity. So a continuous graph, a graph which has no vertical asymptotes, no point discontinuities, or basically any gaps in the domain, or range for that matter, is said to be a continuous curve. You can travel along from the beginning to the end without stopping. Some examples of ones then that would be discontinuous. The hyperbola. I could travel along the left-hand branch, but I can't get to the right-hand branch because of the asymptote, so it's not continuous. This one here, y equals x on x, which has the point discontinuity at x equals 0, because you can't have 0 on 0, not continuous. Again, you could travel along the left-hand side of the branch, but then you've got a problem. How do you get to the right-hand side? And those sort of split functions. Again, how do you get from the left-hand side to the right-hand side? Well, you can't, they're not connected. So they're all discontinuous graphs. Now, why is it important to know about that? Because it brings up this idea of differentiability. In order to be able to differentiate a function, you can only do it at points if it's smooth, continuous. And the other thing that's important is that the tangent is not vertical at that point. So an absolute value curve, now that is continuous. You can travel along that graph without stopping. However, it's not smooth continuous at x equals 1. You've got a sharp point. So it's not differentiable at x equals 1. That sharp point means it's not differentiable. There's the one with the vertical asymptote, x equals y squared. So you've got that vertical tangent there, so we say, well, no, that's not differentiable at x equals 0. And these sorts of curves, what we call a cusp, again, you end up with a sharp point at x equals 2. So that curve is not differentiable at x equals 2. So just a quick word on continuity and differentiability, 9K, 9L.